This is Excel. It's a spreadsheet program, and we'll be using this a little bit later in the semester. And I'm going to have us do a project with a budget. But for today, we're going to talk about how binary works and how the numbering system works. So basically, the computer is a box of electronic switches, and switches, normal switches have one of two values, either off or on, 0 or 1, that idea. Because computers use base 2 or binary because they're made up of switches. Humans, we use base 10. Why do you suppose we use base 10? Anybody? That's right, 10 figures. It goes back to caveman times because we can keep track of, the 10 things, right? Okay, so here's what I'm going to do. I'm going to write a number line. And just forget everything I told you. I'm just going to write this number line. I'm going to go 1, 2, 4. What would be next after that? 1, 2, 4. Okay, 8. Yeah. Okay, 8. What's next? 16. Okay. All right. 32. Do you guys know what binary in here already? That's cool if you do that. Great if you do. 64 and then 128. Now I'm going to stop here, but we could keep going. So we could go 256, 512, 1024, and keep going. But basically, these are going to represent 8 bits together, which is a byte. So that's a good for our vocabulary or whatever. So a bit stands for binary digit. It's a 1 or a 0. But when you have a group of 8 bits together, it makes a byte. Let me go ahead and format this just a little bit here. What I'm going to do is let's move some of this Zoom widgets out of the way so I can get to this stuff here. I'm going to take this and I'm going to center it and I'm going to bold it and call that good. So also, let me actually make it so that we have a little bit of a color scheme happening here. So let's do something like that. Yeah, that'll work. I think everybody can see that. Let's make the text black. We'll do that. Okay, so we can see that. Now, what I'm going to do is I'm going to put, so forget everything I just told you, forget everything about binary and just follow along just for a second. If I want to make 3, I'll put a 1 in the 1s and a 1 in the 2s. 2 plus 1 equals 3, all right? If I want to make 4, I'll put a 1 in the 4s, 0 in the 2s, 0 in the 1s, and then so 4 is 4, okay? What if I want to make 5? I could take a 1 and put that in the 4s. I need 1 more to make 5, so that would be 0 2s, but 1 1, and that would be 5. You see where I'm going with that? Okay, pretty easy. All right, let's do, somebody give me 8 in here. Somebody give me 8. How would I make 8? Dun, dun, dun. Go ahead. Yeah, so 1 in the 8s, right? So, and then it would be 0, and then 0, and then 0, and then this would be 8. Okay, let's get a little bit more difficult. How about, I'll make 7. Let's make 7. I'll show you that. 7, 4. See, 8's too big to fit in a 7, right? But I could fit a 4 in there. What's left over? 3, so I'll put a 2, and then a 1, and that's going to equal 7, all right? So that's 7. Badass. Somebody give me 15. How would I make 15? Or online, someone. All 1 starting at 80 says. Yes, because 16 is too big to fit in a 15, right? But 8 will fit, and then what's left over? 7, and then what's left over? Exactly. So that would be the number 15, right? Okay, cool. Now, here's the thing. If these aren't 1s, what are they? What do they need to be? If I don't have a 1 here, that should be a what? Okay, so really what it is this is 0 0 0 0 0 0 1 1, and that's 3. Okay, and I kind of do this on purpose because I don't want the leading zeros to be confusing. So I'm just filling in the zeros just so that you can see these how they work. Shall we do a couple more tests and see how we do with these? Let's see. All right. Now, believe it or not, we are counting in binary and converting binary numbers to decimal numbers, and that's what we're doing. So I'm going to put right up here, I'm going to put, this is our decimal number. Okay, decimal. Okay, so let's do, somebody give me, try something hard or harder. How about 50? Can we do 50? How many times does 64 go into 50? It won't fit, right? But 32 will go into 50, right? We can get one of those in there. What's left over? I'll have to bring out the calculator. ALC. Let me bring up the calculator, right? So what? So 50 minus what? 32. 32 equals 18, right? So how many? So we got 116, okay, 16, and then 2 left over, right? So that is going to be 50. So 32 plus 16 plus 2 is going to be what number are we making 50, right? 50. Okay, so let's put the zeros in. 0, 0, 0, 0, 0. Okay, is everybody getting it? Okay, so far so good. Really? Okay, badass. Okay, so let me show you something. One of the things they talked about in the video is this thing called ASCII, and ASCII stands for American Standard Code for Information Interchange. So I'm going to write that in here. American, 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 and then standard, STANDARD, code, CODE, and then as for information, and then interchange. Okay. INTERCHE. Interchange. Okay. And so we've had this actually standard for like since the 40s. It's been important because basically what it is going to be it's going to define which binary number, which decimal number is going to be the equivalent to, say, the letters in the alphabet or punctuation marks and things like that, so that we can have a standard so our computers can speak to each other at least, or we can make sense of these. So standards, we're going to find out in computer science, are important. So what ASCII says, and I know this, is that decimal 65 is capital A, okay? That is capital A. And it says that decimal 66 is capital B, and decimal, oops, I shifted over here a little bit. Okay, 67, you see a pattern here, right? 67 is capital C, 68, capital D. So you keep going. Now there are lowercase, but we're just going to work on the caps for now. So let's figure out the ASCII here. So how would I make 65 for capital A? 1 in the 64s and then plus 1, right? So actually, and then if I fill in the zeros, 0, 0, 0, 0, 0, 1, and that's 65, and that's capital A. Excellent. Let's do capital B. So someone else give me 66. 1 in the 64s, okay, and 1 in the 2s, right? Okay, can you give me another way to make 66? It's kind of a trick question. The answer is, in binary, there really is no other way to do that because we can't put a 2 in there, right? So it has to be a 1 and a 0. So that's what's kind of cool about this. There's only one way to make this number, right? Let's do C. So binary C would be decimal 67, capital C. Somebody else give me that. Why don't you give me capital C? 64, 2, and then 1. Exactly. So that is exactly right. 0, 0, 0, 0, 1, 1. Okay, and then I'll do D. How about that? So D is going to be 68. So that's going to be 64. 164 plus 4. That's going to be 68. And then I'll fill in the zeros. Okay, 0, 0, 0. And you could do the whole alphabet like this, right? So here's what I'd like you to do. Take out a piece of paper. Okay, and I'd like you to write out your first name in binary, okay? And you have everything you need to do that right here. So basically, if you keep going, D to E is going to be 69, F is going to be 70. You get the idea. So, and you folks online, I'd like you to do the same thing. Part of the assignment for the lab is going to be to teach this to someone else. You're going to teach someone else how to do binary. And what you're going to do is, like, you cheat actually. You're going to have the number line pre-written. So make sure that you have the number line down. And it's going to help you a lot, because if you do the number line differently, it's not going to work. Here, one of the other things you might notice, let me clear a little pathway here for this. The largest number that I can make with let's say we turn with 1 byte, let's say, if we turned all of these numbers into ones, so we'll take 128 plus 164 plus 132 plus 116 plus 18 plus 4 plus 2 plus 1, and that's going to equal 255, which gives us how many possible combinations can we make with 1 byte of information? 255 is the largest. Okay, this gives us how many possible combinations? Okay, I think in the chat, let's see in the chat. Anyone want to take a guess? 256 possible combinations, because you can have all zeros. Okay, so all zeros to 255 is 256. And the number 255 means for if we have people that are interested in networking computers together, 255 is a special number, and we use that a lot of times when we're working on something called a subnet mask. I find that you really know that you know something when you can teach it to someone else, and so it should be kind of fun. You can teach anybody you like, hopefully somebody that doesn't know it, and that way you can show them how to do that.